Welcome student to Praveen Patil College of Diploma Engineering and Technology. Our obviously subject mathematics, that is applied mathematics, chapter number 2, derivative, myself, Mrs. Smita Shekhar Kar. Y is equal to 1 minus x, 2 plus x bracket square, 3 minus x bracket cube, 4 plus x raised to 5. How it is possible to solve the derivative? So taking the log of both sides, ln 1 minus x plus 2 ln 2 plus x, ln 3 minus x, 4 ln 4 plus x. Differentiate with respect to x. We know that ln of f of x is 1 upon f of x into derivative of f of x. dy by dx. What is the derivative of ln 1 minus x? Is obviously 1 upon 1 minus x. Derivative of minus x is minus 1. 2 remain as the same. Derivative ln of 2 plus x is 1 upon 2 plus x, but derivative of x is 1. Plus, how it is possible? Let us check. Ln 3 minus x derivative 1 upon 3 minus x, ln 3 remain as the same, but derivative of x is minus 1. Minus x is there, no? Yes. Minus 4 ln 4 plus x is there. So it is 1 upon 4 plus x, derivative of x is 1. So we derive the final answer minus here plus and minus is there. Now we have to take the derivative of this term, that is the y, shifting this side, and we derive the final answer in the form. Differentiate y is equal to x raised to 3 by 4 root x square plus 1 upon 3x plus 2 raised to 5. First term, taking logarithm of both sides of the equation using the rules of logarithm we have to apply. Log y is equal to 3 upon 4 log x plus 1 upon 2 log x square plus 1. Why? Because the root it is 1 by 2. And x square plus 1 minus 5 log 3x plus 2. We have to use here log m raised to n is n log of m. Second thing we have to use here the log m upon n is log m minus log n. That's why log mn it is plus, multiplication it is there, so log m plus log n, and subtraction is there 5 log of 3x plus 2. So we have to must know the laws of logarithm in logarithmic differentiation. Now differentiate with respect to x to both sides. Log y 1 upon y dy by dx. 3 upon 4 same. Log x derivative 1 upon x. 1 upon 2 remain as the same. Derivative of log in bracket f of x is 1 upon f of x into derivative of f of x. That's why 1 upon x square plus 1 derivative of x square plus 1 is 2x. Minus 1 upon 3x plus 2, 5 remain as the same. What is the derivative of 3x plus 2? Derivative of 3x is 3 and derivative of 2 is 0. Though that's why 3 upon 4x plus x upon x square plus 1 minus 15 upon 3x plus 2. Now we have to shift y to this side. dy by dx is equal to x raised to 3 by 4 under root x square plus 1 upon 3x plus 2 raised to 5, because we have to substitute the value of y, and final answer 3 upon 4x plus x upon x square plus 1 minus 15 upon 3x plus 2. Find the derivative of y is equal to root x square plus 4 sine square x and 2 raised to x. Taking log of both sides, we know that log what? M into n into r is log m plus log n plus log r. And we have to use the under root x raised to 1 upon 2, and we know that log m raised to n is n log of m. So we have to apply this formula to logarithm to, that is laws of logarithm, to this example. Log y is equal to 1 upon 2 log x square plus 4 2 log in bracket sin x plus x log 2. Now we have to take the derivative of both sides. Log y is 1 upon y dy by dx. 1 upon 2 remain as the same. Log x square plus 4 is 1 upon x square plus 4. X square derivative 2x. 4 derivative is 0. 2 remain as the same. Log in bracket f of x is 1 upon f of x into derivative of f of x. So here f of x is sin x. That's why 1 upon sin x, and derivative of sin x is cos x. Now plus x derivative is 1, log 2 remain as the same. Now x upon x square plus 4 remain as the same, cos upon sin, cot, and log 2 remain as the same. So y dash is equal to dy by dx is equal to y in bracket x upon x square plus 4 2 cot x plus log 2. Next example, y is equal to x log x plus log x bracket raised to x. Now y1 is equal to x log x, y2 is equal to log x raised to x. Apply logarithm on both sides. Y1 is equal to x log x, then log y1 is equal to log x into log x. We know that log x bracket square. Differentiate with respect to x. Log y is derivative 1 upon y dy by dx. So 1 upon y1 into dy1 upon dx. Log x bracket square is f of x raised to n is n f of x and derivative of f of x. That's why 2 upon log x derivative 1 upon x and log x remain as the same. Now dy1 is equal to dx, the x raised to x log x, that is y, 2x raised to x log x remain as the same. Now we have to consider y2 there. In previous example we consider u and v, so we apply y1 and y2 also. y2 is equal to log x raised to x, then log y2 is equal to x log of x. Differentiate with respect to x both sides. 1 upon y2 dy2 upon dx log in bracket log x plus x upon log x. Derivative of log x is 1 upon x, so is equal to log in bracket log x plus xx get cancelled. Final answer 1 upon log x. We know that y2 is equal to log x raised to x. We have to substitute the value of y2. So dy2 is equal to log in bracket log x plus x upon log x. 1 upon x is equal to log x plus 1 upon log x raised to x. So simplify and we derive the final answer. Yx raised to log x plus log x raised to x is equal to dy by dx is equal to 2x raised to log x upon x log x plus bracket log of x plus x upon log x upon 1 upon x is equal to log x plus 1 upon log x bracket complete log x raised to x. Derivative of inverse trigonometry function. Derivative of sin inverse x 1 upon under root 1 minus x square. Derivative of cos inverse x minus 1 upon under root 1 minus x square. Derivative of tan inverse x 1 upon 1 plus x square. Derivative of cot inverse x is minus 1 upon 1 plus x square. Derivative of sec inverse x is 1 upon x under root x square minus 1, x not equal to plus minus 1, 0. Derivative of cosec inverse x minus 1 upon x under root x square minus 1. Example, on derivative of the inverse trigonometry function, sin inverse u is equal to 1 upon under root 1 minus u square into u dash. Tan inverse u derivative 1 upon 1 plus u square into u dash. Cos inverse u bracket raised to dash minus 1 upon under root 1 minus u square into u dash. Sec inverse u bracket raised to dash is equal to 1 upon u under root u square minus 1 into u dash. We take the example sin inverse of 5x raised to x bracket dash, that is derivative, is 1 upon, what is the derivative of sin inverse u? 1 upon under root 1 minus u square. That is 1 upon 1 minus 5x raised to 2. Derivative of the 5x, that is 5. 5 upon under root 1 minus 25x square. Now arc cos tan x 1 upon, obviously that is the under root 1 minus tan square x into derivative of tan x is sec square x. So minus sec square of x under root 1 minus tan square. Now tan inverse in bracket 5x raised to 2. That is u is the 5x raised to 2. So tan inverse x derivative is what? 1 upon 1 plus u square. 1 upon 1 plus 5x square bracket square into derivative of 5x square. 5x square derivative is 2x, 5 into 2 10x plus 1 plus 25x raised to 4. Next, arc sec inverse x raised to 5. Here u is x raised to 5. So 1 upon x under root x square minus 1. It is the formula, or u under root u square minus 1 into u dash. So u here is x raised to 5. 1 upon x raised to 5 under root x raised to 5 bracket square minus 1 x raised to 5 dash. Therefore, what is the derivative of x raised to 5? 5x raised to 4. X raised to 5 under root 5 into 2, 10, x raised to 10 minus 1. In this way, we have to use the trigonometric inverse function to find the derivative. Find dy by dx if y is equal to tan inverse of x upon under root 1 minus x square, y is equal to tan inverse x upon under root 1 minus x square, x is equal to sin theta, theta is equal to sin inverse x. We have to substitute theta is equal to sin theta and theta is equal to sin inverse of x. So sin theta upon under root 1 minus sin square theta. We know that 1 minus sin square theta is what? Cos theta. Sin upon cos tan inverse tan get cancelled. So theta is there. So theta is sin inverse x. Therefore, y dy by dx is equal to 1 upon under root 1 minus x square. So in this way, we have to solve the example based on logarithmic differentiation and the example based on the logarithm, and we have to continue the example based on this format. So we have to remain and derivative of inverse trigonometric function, including this pattern of the solving and example based on these.